Hello everyone. Today we will be showing how to quickly deploy a multi-mesh Gloo Platform environment driven through GitOps using ArgoCD and the app of apps pattern. If you're already here at this repo, you can see that this catalog serves as a collection of solo.io demo environments that can be easily instantiated with a single line command. If I navigate into the environments, I can actually see solutions such as Gloo Edge, Gloo Gateway, Gloo Platform, Gloo Portal, and even just Istio upstream demo. Today we will be doing the multi-cluster Onlineboutique, and I will be showing you how to deploy this locally on K3D. However, the same workflow would work if deployed in the cloud as well. In each directory, environment directory, there's a .infra folder that can leverage K3D under the hood to deploy this locally, and we will be using that today. So keep an eye out on this simple config, which we'll consume when we run the script. From a prerequisites perspective, there's not too many prerequisites, just YQ, K3D, and kubectl, and the Gloo mesh license key. And lastly, to deploy, you just need to simply run the script and pass in the necessary flags. If you just ran this, you would see the syntax of the installer. So let's go ahead and get started. Here I have three terminals where I will deploy my three clusters: management, cluster 1, and cluster 2. Since I already have the prerequisites deployed, one thing that is good to check is your Docker resources. So if you go to Preferences in Docker Desktop, it's good to give about 4 CPUs and 8 gigs of RAM per cluster. So you can see here I have 12 and 40. If I were only just deploying a single cluster Gloo Gateway demo, I would only need 4 and 8. But since I'm doing 3 clusters today, I'll use a larger amount of resources. So let's go ahead and get started. In order to deploy my multi-cluster Onlineboutique demo, all I need to do is run the script. Pass in the correct flags. So giving it a -I will leverage the K3D config if discovered in the .infra folder that I was showing. And then lastly, giving it a -F will allow us to provide a path to the environment. In our case, environments, Gloo Platform, multi-cluster, Onlineboutique, and then the management cluster in this case. Let's go ahead and save that, as I'll use the same command to deploy cluster 1 and cluster 2. And I'll kick off the management install. You can see here that the installer does a quick check for you. If I'm ready to continue, you can go ahead and select yes. As you can see, since I passed in the -I flag, it is going to consume the K3D config and initially deploy K3D with the context named management before bootstrapping the setup. In the meanwhile, I can also run the same commands on cluster 1 and cluster 2 by just pointing at the correct environment directory. So let's do cluster 1, and then let's do cluster 2. And that's it. We'll let this run and come back in a few minutes, and then we will navigate our deployed multi-cluster setup. Now that our environments have been successfully deployed, let's go take a look at the outputs. Once the script completes, you can see in the management output that the installation has been completed and we can access the application dashboard, in our case at localhost. If you're running this in the cloud, you can actually access this through the load balancer external IP on the line below. Now, if I open this, I will get navigated to a link dashboard. This link dashboard actually will connect us to all the other applications running on this cluster. As you can see here, on each of the cluster, I have deployed ArgoCD. The script deploys ArgoCD, and then initially, after the ArgoCD installation is done, it will bootstrap all of the applications required to get a Gloo platform set up and running. The Gloo Mesh UI Expose, Grafana, as well as the Onlineboutique applications spanning across Cluster 1 and Cluster 2. For more information on this environment, you can navigate to the environment directory to Gloo Platform Multi-Cluster Onlineboutique. And if you select the management repo here, you can actually see some more information on the environment description here, as well as the multi-cluster architecture diagram. In this case, you can see I have three clusters, the management cluster, the cluster 1 and cluster 2, which each have the Onlineboutique application deployed on them and set up for service-to-service communication across cluster boundaries. If you scroll down, you can see some more information on the applications themselves for your needs. So let's go ahead and navigate the cluster now. As you can see, if I select the ArgoCD management, I will be routed to the management ArgoCD. Login is admin, password is solo.io. Here you can see that all of my applications on the management cluster are run using GitOps, pointing at this app of apps catalog repo. If you navigate more, you can see information such as my Istio deployment, and so on and so forth. The same case for ArgoCD on cluster 1 and cluster 2, if you do choose to go look at the applications there. Next is the Gloo Mesh UI. You can see here the Gloo Mesh UI has a view of single pane of glass view of multiple clusters. In my case, all three: cluster 1, cluster 2, and management. Load generator is automatically deployed on the Onlineboutique application, so the graph should be visible immediately, and you can actually see here is my cluster 1 and cluster 2 services for the Onlineboutique. And you can see that service-to-service communication is happening across MTLS, across cluster boundaries. As I navigate the UI, I can also see all of my gateways in my multi-mesh, as well as policies that have been deployed. In my case, just a simple failover demonstration here. So now let's access the application. So if I go to the web application on cluster 1, you can see that here Onlineboutique on cluster 1 is designated the name on-prem v1 and it has this green tag for on-prem. I can go ahead and purchase sunglasses, for example. But notice here that when I place my order, the checkout service is actually pointing to the service which lives on the AWS cluster, which is cluster 2. Now, if I go over to Onlineboutique on cluster 2, you can see a different UI served by the AWS cluster with the orange AWS tag. And here you can see if I go purchase a hair dryer, for example. And this also works where the region stays sticky to AWS and goes to the checkout service, which only lives in the AWS cluster. Now, if I go back to the graph, I can actually see the service graph and see that the checkout service doesn't only live on cluster 2. Now let's instantiate a failover. So in my case, I want all traffic coming into this cluster 1 to stay sticky on cluster 1's front end, and only failover on a scenario where cluster 1's front end service goes down. So let's make that happen. In order to do so, I can go navigate into ArgoCD on cluster 1 and log in. And here I can go take a look at the Onlineboutique application. Since ArgoCD automatically syncs, I am going to, on a failover scenario, I'm going to turn off sync so I can instantiate a failover. And in my case here, let's go back to cluster 1. You can see that all traffic is going to on-prem v1's front-end service. And let's see what happens if we take this down. So let's pretend to have a failure here by destroying the front-end service on cluster 1. And if I navigate back to my application and refresh, you can see that the outlier detection was automatically triggered, and now my traffic is flowing even though I'm going to the cluster 1 ingress gateway over to the AWS front-end service on cluster 2. From an operations or a user experience perspective, this is transparent to them. They can continue purchasing and browsing through my online shop. Now let's bring that service back up. So I'm going to sync this in ArgoCD, which will actually redeploy this front-end application. And while I'm doing that, I'm going to pretend back on my user hat to continue purchasing some items from the online store. What you should see is that once that front-end service comes back on, we'll actually be able to swap right back over, no manual intervention needed, and you can see automatically the user coming in to the gateway on cluster 1 now gets swapped back over to the on-prem v1 service. And that's all for today. If you go explore more on the catalog, there's certainly a lot of environments that you can test, such as deploying a multi-cluster book info HTTP bin application, pod info weighted subset failover, or even if you just want to do single cluster demos, there's many more environments that you can try out, as well as take a look at all of the other configuration there that you can set, such as jot policies, transformation policies, rate limiting, and other XAuth capabilities. That's it for now. Thanks, everyone.